Good evening. So this will be our second video lecture. Tonight we're going to be talking about encoding, mainly. How do we get from information that we experience from the world to memories? Good question. So we have this basically a dual track processing model. So one track of our mind processes things a certain way, another track of our mind processes it another way, and we call these explicit and implicit memories that are created by these tracks. So the explicit memories are also called declarative memories. So these are the ones that we can consciously recall, and we're consciously aware that we made them. So we form these through effortful processing, like rehearsing, practicing, studying. So this is all things that you can declare on command. You're aware of them, and you're aware that you're aware of them. This other track deals in the more unconscious realm. These are implicit memories, and these bypass that whole Atkinson-Schriffen model, bypassing working memory, and go straight from sensory memory into long-term memory. And this is done without our awareness. So we do this through automatic processing, meaning that it's automatic. We're not aware that it's happening. It just kind of happens. So if we experience something that's really jolting to us, we may not store it in our short-term memory. It might go right to long-term memory. So if something traumatic, for example, we're unaware that it's stored in our memory, but it's there somewhere. So let's talk about this automatic processing a bit. So as I said, these implicit memories go straight from sensory memory to long-term memory. They bypass our short-term memory altogether and any effortful or working memory processing. So we don't hold whatever memories they are in the forefront of our consciousness. We experience them through our senses, and then they kind of get filed away in some distant shelf of our long-term memory. So these are things like procedural memory, like learning how to ride a bike or knowing the meaning of words. You don't have to think about them. It's just there, right? We remember when we learned how to do that, but it's not like we have to keep working at it. It's just there. Conditioned associations, such as a smell that triggers memories of a favorite place. This happens to me all the time. I actually think it's kind of cool. Information about space. This is a given. We take for granted that we exist in space. So when we're able to picture a room after leaving it, that's not something that we're aware that we're getting those impressions. We can just do it afterwards. We don't have to think about it. Information about time, such as retracing your steps after losing something. You can close your eyes and sort of think about the sequence of events. But we didn't think about it while we were recording those events, but we can recall it afterwards. Also, information about frequency. Like, that's the 14th time I've heard that damn song today. Happens to me all the time. I'm not aware that I'm recording all these songs, or each time I hear this song, but after a certain point, I recognize it, and that's when it comes to my consciousness. So sensory memory. This is where the content of the world, the information that exists in the world, meets our minds, our consciousness. So this sensory memory is immediate, and it's very brief. And this is where we record sensory information before it's processed into the short-term or working or long-term memory. We very, very briefly capture like an echo or an impression of all the sensory data that we're constantly taking in. So very briefly, everything that we hear, that train that you just heard in the background, that's briefly recorded into my sensory memory. How brief, you may ask? For auditory sensations, it's about 3 to 4 seconds echo. So 3 to 4 seconds after you hear something, you still will be able to remember it based on your sensory memory. For visual sensations, it's about 1/20th of a second of an image, so extremely brief we're talking here. So evidence of this auditory sensory memory can be witnessed in what we call echoic memory. Think of the word echo, in which we can usually remember about the last 8 words of whatever someone says, even if you aren't paying attention. So this might happen to you in class. If I catch you dazing off with your head down, and I say, "What did I just say?" You may be able to repeat about the last 8 words that I said without even being aware of it. Now, to really get you, I would ask you, "What did I say before that?" And then you'd be stumped, and I'd look like the cool teacher, and you'd look like the slacker. All right, so how do we have evidence of this visual memory? So this guy, George Sperling, conducted an experiment. in which he exposed people to a 1/20th of a second view of a grid of letters, followed by a tone which told them which row of letters to pull from iconic memory and recall. Without hearing this tone, people only recalled about 50% of the letters. With the tone, they can recall, for any of the rows, about 100% of them. If you want to test your iconic memory skills, I've included a link here. I haven't figured out how to actually link, so you're going to have to type that in manually. But test out your memory skills, see what you got. So we also have figured out in psychology exactly how much information short-term and working memory can hold. So this guy George Miller, he conducted an experiment, and based on his findings, he proposed that we can hold about 7 seconds plus or minus 2 seconds of information bits, like a string of about 5 to 9 letters. So this is very important. It's one of those psychology catchwords. You remember George Miller's magic number 7. George Miller's magic number 7. You should remember that. But more recent research suggests that the average person, free from distraction, can hold about 7 digits, 6 letters, or about 5 words in their short-term memory. However, working memory, and I realize there's a typo there, which uses rehearsal, focus, analysis, linking, and other processing, has greater capacity than short-term memory. This capacity varies from person to person, as some people just have better concentration skills. Some people are just better at keeping things in their working memory. And this comes from practice. And again, if you want to test your short-term or working memory, I've included a link here that you will have to type in manually. How about the duration of short-term memory? Meaning, how long can we remember something? So this couple, husband and wife, Lord and Margaret Peterson, conducted an experiment in 1959 to determine the duration of short-term memory. In this experiment, people were given triplets of consonants, for example, BMH was one example. To prevent rehearsing, the subjects had to do a distracting task. And then people were tested at various times for recall. What did he find? That after 12 seconds, most of the memory of the consonants had decayed and could not be retrieved. And here's a little chart showing that. So you can see that as time went on, more memory was gone. He called it decaying. So this tells us that short-term memory is very brief and it only stays within our consciousness for a short amount of time. However, there's ways to effectively boost your short-term memory. Since we have a short-term memory recall of only about 7 letters, but we can recall 5 words, logic says that we should be able to remember more than 7 letters if we group them into words. So such an example of this is an example of effortful processing strategies. And this is a way to encode information into memory to keep it from decaying and make it easier to retrieve. This is also known as studying. As an AP student, I'm sure you are painfully aware of this process. So some examples of some effortful processing strategies, or studying: chunking, mnemonics, hierarchies, rehearsal, deep processing, semantic processing, making information personally meaningful. So, since this is such an important area for you as AP students, I'm going to go into each one a little bit more deeply. And maybe you'll find one or another, maybe a couple, very useful for you. So the first one, chunking. Numbers in chunks or groups, like credit cards, social security numbers, phone numbers, are easier to encode or memorize and recall than individual digits. It's very difficult to remember a phone number, but if you use the sort of cadence or tone, 845-338-5732, 845-338-5732. 5732. It's easier than 845-338-5732. But even there, it was difficult for me not to chunk them because I've done it for so long. So chunking is organizing data into manageable units, little discrete bits. So try to memorize this sequence of letters. I'll give you a couple seconds. Got it? Okay. Now, chunking works even better if we can assemble information into meaningful groups. So, now try to do it. It's probably a little bit better, wasn't it? These are all meaningful to us. We all know what the NYPD is, NFL, Some of us know what NCIS is. I don't like that show. The FBI, BT Dubs, and FYI. These are all very meaningful, short little groups of letters that we identify. So if we group letters into meaningful groups, they're easier for us to retain. So another device that we can use is called mnemonics. So read these words and try to remember them. Plain, cigar, do, shall, vague, pizza, seam, fire, and pencil. Okay, they're going to go away. Try to remember them. Which words might be easy to remember, do you think? Write down all the words you can recall now. I'll give you a couple seconds. Were the words you remembered easily imagined? Wow, I butchered the spelling there. I apologize. I found that the words that I could remember most easily, I associated images with them. So the cigar, the pizza, the plane, fire even. Words like shall and vague, I have nothing to connect them to in my mind, so I guess I just didn't remember them. So what's the lesson here? We encode better with the help of imagery. So, you ever heard of a mnemonic device or a mnemonic trick? These are memory tricks that connects information to existing memory strengths, such as imagery or structure. I call this a hook. You have to hook the information to something that's already in your mind. So this is a trick that teachers use pretty regularly. So when we try to remember something, if we can associate it with something that we already do remember, it'll make it easier for us to recall in the future. So now we have rehearsal and distributed practice. So mass practice, also known as cramming, refers to cramming information all at once. Not a good idea. It is not time effective, and research has shown that you will not retain hardly any of the information. I shouldn't say that. You'll retain maybe half. Let's say that. However, the spacing effect, it was first observed by Hermann Ebbinghaus in the late 1800s, and he found that people develop better retention and recall, especially long-term, if they use the same amount of study time spread over many shorter sessions. So rather than cramming 4 hours in one day, you would take this and distribute it maybe over 4 days, an hour a day, and that would be much more beneficial to you. Now this doesn't mean, though, that you have to do it every day. Another researcher named Harry Barrick noted that the longer the time between study sessions, the fewer sessions that you need, and the better the long-term retention. So, as you have that month off between the AP test, don't stress, because you're still retaining information. And one of the best ways to practice or study can be found in considering the testing effect, which was first observed by Henry Roediger. He found that if your distributed practice includes testing yourself, that is, answering questions about the information that you're reading, you will learn and retain more than you would by merely rereading the material. Another typo there. I apologize. I'm rushing through this. However, if you're reading your psychology text and you're reading it with a buddy, for example, and you ask each other's questions, you have to recall that information. When you're just rereading a page over and over and over again, you're not hooking that information to anything, so it just kind of stays in your short-term memory. It doesn't get lodged in your long-term memory. But if you answer the questions and sort of form these practice answers to the questions, the information will be hooked to something in your long-term memory. Another method is deep or semantic processing. When we encode information, we are more likely to retain it if we deeply process even a simple word list by focusing on the semantics or the meanings of the words. Shallow or unsuccessful processing refers to memorizing the appearance or sound of a word. Deep processing refers to memorizing the meaning of a word. So here we go. When you have a shallow processing, you're looking at what the word looks like, what it sounds like. Semantic, you're memorizing the meaning, and this will allow you to memorize it better. And last but not least, if you make things personal, again, you hook it to something that already exists in your mind. So you can memorize a set of instructions more easily if we figure out what they mean rather than seeing them as a set of words. Memorizing meaningful material takes 1/10 the effort of memorizing nonsense syllables. So, actors memorize lines more easily by deciding on the feelings and meanings behind words, so one line flows naturally into the next. We have the self-reference effect. We have to relate material to ourselves.